All right. Add on the picture.
If you look through 11, I don't know. My brain doesn't work.
Okay. So again, the factoring right here on number 11, first thing we should notice is it's a binomial. And with that binomial there, again, depending on what you are missing influences how we do need to factor that out. So as we work through the factoring there, we are missing the constant term, the C. And again, as we miss that constant term, what we've got then is the GCF. It's got to be the GCF. Now, with that GCF there, don't forget we're making sure we factor out the greatest common factor, and the mistakes that usually students make then is not factoring out, say, the 8 all the way, bring out maybe some 2 or just a 4, but it's got to be the 8. And then also making sure you bring out the n as well. So 8n is the GCF. You are not factoring that out, say, with factors of A, B, and C. It's got to be the GCF, again, when C is not there. All right, real quick, anything else anybody's got? So we just go in here for today's notes. Today's going to be the big push with functions. Okay, as always, make sure your name's on it. Let's throw into the basket. Let's get your notes out. And with that, talking about functions, everything that you guys have done in the years is considered to be a relation. A relation can be a table of values, like I have here. A relation can be a graph. A graph can look like, just like we've done before. It can be a line. It could be a U shape. It could be just a bunch of points. Okay, those are all different types of relations. Other things that are relations, a word problem can be a relation. All right, a relation is just bringing to a relationship between certain quantities. Now, with relations, they get classified as a function when something specific happens. And that's usually what we focus more on math is when does a relation become a function? So that's what we want to talk about here today. And then after that, talk about domain and range as well, and looking at domain and range. And we're going to bring in that interval notation that we talked about yesterday. So a function, all right, it's usually best just kind of do some examples of when something is a function, when something is not a function, instead of reading through the definition of a function is usually not terribly clear. It's usually better to do some examples of when something is and is not a function. That usually is when it kind of clears up things, okay? And then we're also going to again talk about what is the domain and range. Domain and range is always out there. It doesn't matter if something is considered to be a function or something is not a function. Domain and range is always happening. So the domain is your x values. This is your domain. Your domain is your input. Okay? Your range is your y values, your output. So at some point, usually about 6th grade, you start to learn about linear functions, lines, and they usually talk about like an input-output machine. That's typically how things usually start. And we have a domain, we have a range, an input and an output. Now in this table right here, this relation we call a function. And in this table, we said this is considered to be not a function. So why we say one table is and one table is not a function? All right, let's look at these domain values, these x values, and how they go over to the y values. In this domain, we have all unique values. Nothing is, say, getting repeated. -3, -1, 0, 1, 5. Over here in this table, though, we've got what being repeated. We've got that 3 being repeated, right? That's what you want to keep an eye out for. Where does that 3 go to? 3 is going to 4, and 3 is also going to, that cannot happen to be considered a function. That input cannot go to 2 different outputs. That domain of 3 the phone away, Silas. That 3 cannot go to both 4 and 7. It can only go to one specific output. So here, that is why that function, sorry, this table is considered to be not a function here. We still have a domain. That doesn't change anything. We still have a range, but this is where things are screwing up. Okay? So that's what we want to keep an eye out for today is when do we have a function, when do we not have a function. But what we primarily work on throughout most of our math is different types of functions. And what you guys have grown up with so far throughout your years of math has been the linear function. And as you guys roll into next year, you're going to look at quadratics, exponentials, absolute values, cubics, square roots, and tons more. All right. Now, let's quickly roll through here and create a table that is a function. So let's create a table that's a function. All right. Let's just go down the line. Aylin, just give me a random number. Aylin. 8. Alex, give me another number. And then Lily, give me a number. 12. Lily, give me a number. 15, I think. Cool. So as you all gave me different numbers, thank you for giving me different numbers. We are on our way to creating ourselves a relation that is a function. All right, Grace, continue on. Give me a number. 2. Nate, give me a number.
6.
Nice. Blake?
9.
And then
7.
7. Okay. So from there, we've created, again, a table that is considered to be a function because right here's where it started off at. The numbers y'all gave me to create the domain, they were all unique. And as we look across, we're good to go. Now we want to create a table that's not a function. Let's continue on where we left off at. Max, so Myra, give me a number. I'm sorry? 4. All right, Naeem?
4.
What's that? 4. Andrew? 8. And then let's wrap it around. 8. Okay. Now, I'm glad we got some things happening here because you just didn't say any random number. It necessarily couldn't be any random. What do we have to have here? We had to have some repeating numbers. Now I have 4, 4, and 8, 8. As soon as I had at least just one number repeating, okay, we are looking pretty good here. Now on the range, all right, let's continue this on. Adeline, give me a number. Jackson, give me a number. Just give me a random number. 3. All right, Eric. 6. And then finish it off, Brianna. Okay. So from there, 4 cannot be going to obviously both 12 and 3. That's cannot happen to be considered a function. Now, let's just change this up really quick. Still not considered to be a function because 4 is going to both 12 and 3. What if I did this though? It's a function. So I've got 4 repeated, yeah. But look to where it does go though. This is where somebody maybe just copy paste this value down, but it's the exact same value, right? So if you were to look at this and say, oh, 4 is repeated, look to see where it goes though. 4 going to 12, 4 going to 12. We've repeated ourselves, yes, but it's the same y value. And as Adeline just said, that is actually still considered to be a function. So what needs to happen though is to be not a function, it has to go to a different y value then. Okay? So look carefully at also that y value right there. Okay, let's go away from the table and let's look at it in terms of a graph, from a viewpoint of a graph. Let's see if anybody remembers using your vertical line tests. Now, as sophomores, you definitely should. And ideally, my freshmen, you should remember the vertical line test that this usually goes hand in hand with learning about functions for the first time. Okay, take your pencil, okay, put it vertically on your notes, put it on the left side of the graph. What you want to do is drag your pencil from left to right. In order to be a function, your pencil vertically should only hit that graph 1 point at a time. So when I drag that pencil across this graph, it is only hitting that graph at 1 point at a time. At any time, is that graph and pencil hitting it more than once? No. 1 point, 1 point, 1 point, 1 point, 1 point, 1 point, 1 point. This is then considered to be a function. Okay. What about letter B? Take your pencil, again, line it up always vertically. We call it the vertical line test. Drag it across that graph. 1 point, 1 point, 1 point, 1 point, 1 point. This is considered to be a. Now we did the exact same thing up here at the table form. We did the exact same thing here on this graph right here where it failed, except we didn't use a visual vertical line test. We just took a look at 412 to 4 negative 12. Well, on the next page, I'm pretty sure this one fails my vertical line test. Because when I drag it across, well, it fails every which way, doesn't it? Right here, it fails because it's hitting vertically at 2 points at a time, and it can't do that, bless you, to be a function. What do I mean by fails? Again, at this location, -5 on a table, what do we have? -5, comma 3, and -5, comma what? -3, don't we? In table form, we said a second ago that can't happen. Go ahead, Jackson. Visually with the vertical line tests, that's what we mean. This cannot be happening with our function. So we say not a function. Okay. Using your pencil vertically, or just your finger, obviously. How about letter D? Put your pencil vertically. Is this graph considered to be a function, yes or no? Definitely not, because it's really screwing up. How many points is it intersecting? 3 points. Every which way it's happening, it's failing. You can only do it 1 point at a time. This is not a function. Okay. Now let's go back to the other page for a second. These two down here that we classified as functions, this is what you're going to run into next year. If we had the extra time, which unfortunately we don't, we would tear this one apart and talk about it and analyze it. Anybody? What's that graph called? We talked about it a little bit this school year. It's U-shaped. We call it a. My sophomore should know it. It's called the quadratic function. And what have we been doing all second semester? First semester and second semester? Quadratic function. Okay, that's our graph. The quadratics I just had you factor last night. Okay, the other one, letter B. We have not talked about that in Algebra 1, but you're going to do a lot of work with that next year in Algebra 2. That's one of our popular ones. Now, throughout the school year, very beginning of the school year, we started working with this dude, though. Not the graph of it, but the equation solving it. This is what we call the square root function. Okay? So, next year in Algebra 2, just like I told you with the special rights, 1, 1, 1 root 2, 1, 1, 1 root 3, and 2, like you should know those like that. That's where you're going to be at next year. You should know quadratic is U-shaped, it's x squared. You're going to need to know square root is the square root of x, it looks like that curve. That's where you're going to be working on next year with that. You got the door perfect. All right, so let's take number 3. Just draw me a quick shape that's not what we talked about. That is considered to be a function. Draw me any shape that you want, but make sure it passes the vertical line test. And do not draw me a shape that's already on your notes. Don't go lazy. What's that, Sam?
I wasn't trying to go lazy.
I know, but give me another shape that's not in your notes that is considered to be a function. There's more than one option out there. Give me a quick second there and draw me the shape that's considered to be a function. That's also not on your notes. All right. Quick shape, that's considered to be a function. Now my, again, sophomores, you should have another one that's out there. It's not U-shaped, but it's like a U-shaped one. What's our other one? Maybe you remember from last year that's U-shaped, not U-shaped, but it's V-shaped, right. It goes hand in hand with the U-shape. It's not quadratic, but it's V-shaped. Do you remember what that one is called? Remember that family's called? V for, this is my absolute value function. Does it pass my vertical line test? Sure does. Okay. U-shape, quadratic, V-shape, absolute value, V for value. They go hand in hand. It's the same type of graph. So if you, whatever shape you just drew on there, does it pass the vertical line test? You're good to go. Another major one that we do in Algebra 1 is this curve right here. My Algebra 1 kids should know that one, my sophomores. This is the exponential curve, the exponential function. That's the other, we got 4 major families in Algebra 1 we learned about. The exponential function is the other major one. Quadratics, absolute value, exponential, and the other one we've talked about, well, it's just a linear function. Which you guys is the very first function you learn about into 6th grade, this linear function. Okay, create me one number 4 that's not a function. Draw me something that's considered to be not a function that's not on your paper. Go. Again, it doesn't have to be anything crazy, as long as it does not pass the vertical line test. You can take that quadratic and turn it on its side. So U is on its side. Take the V, turn it on its side. That's usually one of our go-tos. Okay. We're going to talk about that next, not necessarily maybe next year, but the following year. But it for sure does not pass our vertical line test because I got points at 1, 1 and 1, -1. Or one that I usually go with is kind of like the Harry Potter lightning bolt there. Okay. Where does it fail the vertical line test? It's good right now. It's good right now, but it fails right in between here. And then it's fine, but because it fails at one time, you're done for. It's not a function. Okay. So that's how we take a look usually of when it's a function or not. Just give you a bunch of examples. So those are when we have functions and we don't have functions. All right. Now let's get into start analyzing functions. All right, let's analyze. So this is really now where today we want to be at, is analyzing. We want to first say yes or no, do we have functions or not, and then we want to talk about domain and range. This is where we want to be at now the next few days. All right, let's take a quick run through. Take A, B, and C. Just do yes or no. Tell me function or not. Run quick through A, B, C, yes or no. Should be a quick yes or no. Don't just stare at me. A, B, C, yes or no. Take your vertical line tests. Okay, so what is it? A, yes or no?
Yes.
B,
No.
and C.
Yes.
Okay, now let's talk about the domain and range here today. All right, beginning the lesson, we said the domain is looking at the x values. So I always like to just state right there, the domain is focused on the x's. You got to train your eyes to focus on these x values. Okay. So what I mean by x values, if we were to take all the x values needed out of this graph that's needed to make it, and we put it into table form, what x values are we using there? We want to write it in our interval notation. So x values is from left to right. What is the leftmost x value? What is the rightmost x value? So when I look at this from left to right, what's the leftmost x value? Look closely. So think about this right here. Where does this graph start off with on the left? Negative 5, comma. And then read it from left to right. This graph, yes, it goes up, it goes horizontal, it comes down. Don't care about that. All I'm reading is it starts at negative 5, and then it stops on the right and stops at what x value? Positive 5. So when I say identify the domain, I want to know what's the left x value to the right x value. Now we're using our interval notation from yesterday. Parentheses and brackets. Now when you said negative 5 there, look at that point, just like we talked yesterday. Is that point open or closed? And what does open imply? Parentheses or bracket? Okay, that's it. You said positive 5. Is that open or closed? And what did close imply? That's it. Okay. So what that means is that domain that I need to make this graph, I only need to use negative 5 to 5 to make that graph. Don't get greedy. Did I need to use out here at negative 100 to make that graph? No. Only use what you need to. All right. Now the range. The range is the y values. And this is usually where students kind of mess up. So it's a lot of practice here. The range, bottoms up, people. Floors and ceilings. We have a floor, we have a ceiling. Range is, again, bottoms up, from the floor to the ceiling. What is your bottom y value? What is your top y value? We do the exact same thing we just did with the domain, but you go from the bottom up. So we have a floor right here. What is this floor? What is that minimum y value? Negative 2. And then we go up, 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 and then we stop. Where's my graph stop at? A y value of 2. Now we got to come around and put either parentheses or brackets. Now let's look down there at negative 2, because at negative 2 there's a lot of things happening. I see an open dot, I see a solid line, I see a closed dot. So what do we use? Do we use open or parentheses, or do we use a bracket? If you have opens and solids, solids always take priority. So what does that mean we're going to use? We're going to use a what? Bracket. If you see solid, solid takes priority. Okay. Up there at the ceiling, you said it stops at a y value of 2. And up there, we have a solid horizontal line, don't we? And what does that imply? A bracket or a parenthesis then? It's all solid, right? And solid means a bracket. Don't overthink it. If it was open, then it would have looked open. Or what they would also use is made it dashed. Dash means also open. Solid means closed. All right, that's one down for domain and range. If you've never done that before, I don't expect you haven't mastered yet. Let's go do another one. Okay. Let's do letter B. Now you said it was not a function. That's fine. We still can identify domain and range still. Let's go do domain from left to right. Okay. What is your left domain value? What's the leftmost part of this graph at? Negative what? Yep, it starts right here at negative 4, comma. Now, make sure you get the rightmost x value. It's not at 2, it's at 3. And if it's helpful for you to draw on those like vertical lines I've been doing to try to draw your eye to that, then draw on those vertical lines. Come back around, what do we have? Brackets, parentheses. Okay, at -4, you told me. Now I don't see necessarily like a dot there. It just looks like a turn, but it's solid, isn't it? And if it's solid, what's that mean? Okay. If it was open, they would have an open dot there. Because there's no open dot there, it's solid. You told me 3. This graph continues right here at 3. And when it stops here at 3, what's it showing there? Parentheses. Okay. Bottoms up. Let's do the range. Floors and ceilings. What's the bottommost Y value? What's the topmost Y value? Floors and ceilings go from bottom up though. What's the bottommost Y value here? -5. Comma. Up, 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 up. And we're stopping here at a ceiling of 5. We need just those specific Y values to make this graph. Come back round, parentheses, brackets. Down here at -5, that starts with a open dot, which means parentheses. And up here, where we hit the ceiling, it is a open dot, which means also a parenthesis. That's my domain, that's my range.
So on A with the -2 at the bottom, but so there's open and closed. Does closed make priority?
Always does. It's at the same level there. It takes priority. Yep. Letter C. This is, now these graphs are nothing special named. This one here, it's that kind of that kind of like that curved arrow. This is called the square root function. Get to know that graph because it is going to hit you a lot in Algebra 2 and beyond. All right, let's do this domain. All right, so this domain, it's the axis. All right, let's change up our domain though. This domain, from left to right. Okay, is it starting here at -6 though? No, what does this arrow tell me to do? This arrow does not start off here, stop at -6. It's starting way out here at, yeah, think about what we did yesterday. It doesn't start -6, nor does it start -10 or -100. It starts out here at, as I heard somebody say, -infinity. That's where that graph's starting at. So now we're going to bring in these infinities now. Okay? Because of that arrow, we're starting way out here at -infinity. Now read this graph from left to right. We're coming in from -infinity. Now we get to this -6, -3, 0. But we do have a stopping right value. Where do we stop at on the right? We stop at 4. Infinities always get a parenthesis. 4 gets a what? That thing, a bracket. Okay. So our domain, that graph continues on that way forever, so I need infinity out there. Bottoms up. Let's do the range. Okay, on the range, floor to ceiling. This graph is not starting anywhere down here. It's starting right there at that level for a floor. And then it starts to go up, up, up. Now, do I hit a ceiling right here? Is my ceiling here at 3? No, what's it going to do with that ceiling? It keeps going up. So no ceiling, whoops, no ceiling here. Do I have a ceiling at 4? Or 5? Or 6? Or do I have a ceiling at all? Where is it going towards? So we're starting and going all the way up to, where are we starting at the y value actually? We're 0. So we're starting at 0 and going all the way up to infinity. Now when we start off at 0, what is that 0 getting? A parenthesis or a bracket? It's a bracket because you can clearly see it is a solid point. And infinity, I don't care what it is, always gets a parenthesis. Alright? Alright, let's do a couple more here. Let's do letter D. Okay, letter D, that's a cubic function. We're going to get into cubics next year. It's a cubic function. Alright? First off, is that, well, I just said it, it's a function. So yeah, it's a function. Alright, let's do the domain. This is where they start to get maybe a little odd. Domain, where's my left x value? Now, are we starting right here at -5? What's this graph still doing? Yeah, I'm going to exaggerate this out. This graph is still going to the left. Don't care about going down at the moment. Domain is left-right. But this graph is still opening out to the left. And it's starting to left at negative infinity. Domain's the x's. And to the right, it's not stopping at 4. There's no stopping at 4. Because this graph is going up, up, up. Yes, it's going up. I don't care. It's still going to the right. So I'm going to exaggerate this to the right. It's still going to the right towards infinity. What does that tell me? I need every x value in existence to make this graph. I need from negative infinity to positive infinity to make this graph. And infinities always get a parenthesis. Range. Range, I need bottoms up. Range, I need, okay, do I have a floor here? The arrow tells me I have no floor because this thing is not starting at -6. The range keeps going down and it starts way down here at negative infinity. Do I have a ceiling up here at 6? No. The arrow tells me continue going up forever. Forever means this is one of the graphs where I need literally every x and y value in existence to make it. Okay? I need to have every x and y value to make that graph. Alright, let's do one more here, letter E. Function, yes or no? We got a function. Now, that function is actually quadratic. It's not a full quadratic, it's a partial quadratic, but it's a quadratic. The domain, let's finish this thing off. Left to right. Now, on this one, we can clearly see it's not an arrow, but it's a single dot that terminates. So what are we doing? We do have a starting point at -3. And on the right, we have an ending point at 2. So at -3, what's it get? A parenthesis or bracket? And at 2, what do you get? Parenthesis or bracket? It's open, so yep, it's a parenthesis. Floors and ceilings, bottoms up. Okay. Bottom here at -5. Go up, 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 up. I get a ceiling here of 4. I'm not going past that 4. -5 is a parenthesis or bracket. And 4 is a bracket as well. All right. That's day 1 of domain and range. Analyzing. Monday, we're going to do some more work with functions. We're going to talk about function notation and go from there. All right. We pass out the assignment for today. And same deal. Assignments online, use it, don't abuse it.